In this video, I'm going to talk about natural language processing. Natural language processing is not typically the topic that is covered in standard machine learning courses, although it is a very important part of it. And the reason is that it is really one course for itself, at least one course. It is a whole field of things that you can learn and you can try. But I'm adding it to this course here, and this would be a very brief introduction, just because that it is gaining popularity day by day, and this is something that as experts in machine learning you would benefit to know about, and even probably later to apply it to some of your projects, especially if you're going to industry. Many businesses now require applications that incorporate natural language processing one way or the other. So uh, by that, I want to say that this video is definitely not a full learning tutorial or even introduction to natural language processing, just to familiarize you with the field. So let's get started. By natural language, we mean languages that are used for everyday communication by humans. Languages such as English, Finnish, Swedish, Hindi, Portuguese. In contrast to artificial languages such as programming languages and mathematical notions. Natural languages have evolved as they pass from generation to generation, and it is really hard to pin down with explicit rules uh, these sort of languages. We'll talk about natural language processing, or NLP for short, in a wide sense to cover any kind of computer manipulation of natural languages. At one extreme, the application of natural language processing could be as simple as counting word frequencies to compare different writing styles. At the other hand, NLP could involve understanding complete human utterances, at least to the extent of being able to give useful responses to them. Technologies based on NLP are becoming increasingly widespread. We are seeing them anywhere. For example, phones and handheld computers support predictive text and handwriting recognitions. Machine translations allow us to retrieve text written in Chinese and read them, I don't know, in English or vice versa. Voice assistance applications like Siri, Alexa are here to stay, and we are seeing them being used more often by day. By providing more natural human-machine interfaces and more sophisticated access to stored information, language processing has come to play a central role in multilingual information society. So they are, as you see, are becoming one of the foundational pillars of our society, and it's good to know what they are and what can be done with them. So what is natural language processing, or NLP in short? If you look at Wikipedia, it's going to tell you that it is a field of computer science, artificial intelligence, and linguistics concerned with the interaction between computers and human natural languages. You should also keep in mind that natural language processing concerns various computational methods for analyzing and generating natural languages. NLP does not necessarily involve machine learning, but often it does, so that is why I'm including it in this course. It is also it is also very pronounced in research fields. For example, one example is called the Catching the Red-Priest, and this is when historical editions of Encyclopedia Britannica was used to track the evolution of reputations. It has also been used to predict the political alignment of Twitter users, and also detecting influenza epidemic using Twitter. It can also be used and has been used in research for identifying the fraudulent financial statement using linguistics. And finally, the application that I forgot to put animation on from the beginning is the credibility analysis. So, why shall we use NLP? Why is it important? You need to keep in mind that most information is nowadays stored as free text, and intelligent systems must be able to communicate in a human-like manner, whatever that is. Natural language is considered by diversity and ambiguity, and so this is the thing about it. It is very diverse and it is ambiguous in most of the cases. Uh, and this diversity and ambiguity is not encountered in structured data. For example, time flies like an arrow, and if you were a machine, probably it would have been much more difficult to understand what the sentence is talking about. Uh, what is needed for natural language processing? And for now, we are only focusing on text data, but keep in mind that we have a speech recognition that's using natural language processing, and then that is really not necessary textual data. But let's focus on this. We need textual data. We need appropriate methods to figure out what's going on in that textual uh, data, and more often than not, it requires manual labor. Uh, one thing that you're going to hear a lot when it's a talk about natural language processing, let me say NLP from now on, it's quite a mouthful, is the text corpus. And what is a text corpus? Uh, like the Rosetta Stone, it's a collection of natural language texts. It may contain annotations, which are the structured information regarding specific segments of the text. And it could be proprietary or public, and it must be appropriate for the given task with regard to language, text style, content, available metadata. Remember that publicly available text sources could be used to supplement your your proprietary data. And some examples of NLPs could be text segmentation, morphological analysis, syntactic parsing, information retrieval, text summarization, information extraction, sentiment analysis, machine translation, speech recognition, text generation, question answering. The list is long, and it is becoming longer every day. So let's talk about text to data NLP. Uh, First of all, we need pre-processing when we are doing text to data. And why is that so? First of all, because text on its own is initially just a sequence of characters. Machine learning methods commonly require numeric data, and that is not how the text data is. And linguistic analyzers can be used as pre-processing steps in textual data mining applications. And finally, tasks and their solutions are typically well established. So let us discuss about some basics of NLP for a text, and these are the things that uh, you need to know at least the meaning. Doesn't mean that you're going to apply all these things in one single text that you are getting to analyze, but these are the approaches out there. And they are sentence segmentation, word tokenization, and you have done a bit of that in one of your hands-on practices last week. Text lemmatization, stop words, dependency parsing in NLP, named entity recognition. This is what I said that we're going to talk about more now, and conference resolution. So let's start by sentence segmentation. Sorry. The first step in natural language processing is to split sentences into separate objects. This stage is quite easy actually. A smart AI algorithm screens the datasets and defines punctuation marks. Each time is noticed as a period, it considers a sentence finished as separated from the whole text. This stage is quite important because it allows the NLP model to derive the meaning of the sentences and get down to the analysis of the whole paragraph. Breaking text into sentences could be very easy when data comes in a more or less a structured format. However, the information might be presented without punctuation marks or lack other elements of the text. In such cases, data scientists typically apply complex techniques to identify meaningful parts. Word tokenization is what you saw already. It is once you have the text broken into sentences, then it is time to separate words and determine the parts of the speech. In English, this is easy to do by identifying the spaces between the words or token. Interestingly, punctuation marks are also considered separate tokens as they carry certain meanings and can change the whole idea of the text. Because, for example, uh, uh, where you put the comma could totally change the meaning of the sentences. Uh, okay, where was I? Okay, and after we did this first step, the next step in NLP is to look at each token separately and define its part of speech. AI algorithms analyze each word and apply a certain set of criteria to categorize it into adjectives, nouns, verbs, etc. This will help a machine understand the role of each token in the sentence or text. For this purpose, a pre-trained parts of speech classification model is normally used. Uh, this model has been trained by processing millions of English texts previously tagged and marked to provide the algorithms with essential data. It analyzes large data sets, which helps it to develop statistics that are further used to define which part of speech a word belongs to. Uh, One thing that I want to tell you here, of course, these are the stories we're telling of what each of these things mean and what they do. uh, you need to know them. You need to know why they are used when they are used. You probably at this stage don't need to know much about the mechanisms behind them, but definitely you're going to use them when you're doing some coding. They could be simply as importing part of the module for tokenization, but still you need to know that this is something necessary in the process of NLP. The next thing is text lemmatization. Most texts and sentences contain root words as well as words with different grammatical forms. Natural language processing is used here to help the machine identify meaning and categorize these words. For example, you might see the words population and populated in the same text. Although they belong to different parts of a speech, the meaning of these words are quite similar. NLP models are applied here to figure out the lemma in a sense of each token, which is the basic form of each token. This helps an AI system understand the central concept of the text. The next term that I'm going to talk about is stop words. This is also an essential step in NLP, which identifies stop words and filter them out before decoding the central meaning of the text. Uh, each language has a number of linkers and fillers that do not add any extra meaning to the text, but they appear frequently in a speech or in a casually written text. Such objects might produce a kind of noise which will hinder an NLP system from deriving insights from the data. So NLP pipeline usually mark these tokens as stop words and skip them when analyzing your text or any other piece of data. For example, if somebody transcribe what I'm saying now, there are a lot of, let's see, and these sort of things that, I mean, if you remove them, nothing is going to happen to the text. Another thing is the dependency parsing in NLP. Dependency parsing is what data scientists do next in NLP. The primary task here is to discover the relation between all words in the text. For example, uh, uh, NLP algorithms build a parse tree which define the root word in the sentence and bridge the gaps between other tokens. They may also define a parent word for each token to gain more insight and subsequently to understand the core concept. And another thing that I'm going to discuss here, we're almost there, is named entity recognition. When we have a ready-made parse tree, it is time to move on to named entity recognition. At this stage, data scientists start extracting ideas from the text by relating tokens to real-life objects. For example, the words Milan and Italy refer to geographical places, while Western Roman Empire is the historical name. By extracting this sort of information, an NLP model derives extra meaning from the text, which could further be used to conduct thorough analysis. And finally, I want to tell you about conference resolution. Basically, after we have finished named entity recognition, we have plenty of information at our hands. We have split the data into sentences and words, derived their meanings, built relationship between the main subjects in the text. However, we still have one obstacle that prevents our NLP from a complete understanding of the language. Each language has many entities, such as pronouns and other parts of speech that may relate to another word in the sentence and expand its meaning. Conference resolution is performed to cluster all mentions in the text, which refer to a real-life concept or entity. So, by doing so, NLP model will understand what words like he, its, or thus refer to. Okay. Here is an example. It is how the data has been broken down. The sentence is, the earphones broke 2 days ago, and you see basically it has been split to different, the sentence has been split to words, and then basically we have the parse tree here, but at the same time we know what each word is. For example, DT for there, that refers to determiner, and an S is for noun, but for the plural noun. VBD is for verb in the past tense, broke. CD is a cardinal number, and an S again is a plural form. Sorry. And RB is the adverb. So basically, this is how the after breaking down, we basically find out what type of words we are dealing with, then how they are related to each other. This is days for earphones, basically 2 days ago or kind of together something, but this is the adverb for the whole thing. So these sort of trees that are the model is going to be built to build itself. Okay. And a common source of machine learning features, as we already discussed, are token characteristics, whether the word is capitalized, uppercase, mixed case, or what. Then lemmas, as we already discussed, then part of speech tags, like what you see here, then syntactic dependencies, which are here, lexicons, document metadata, and appropriate feature representations are generally very task dependent. So there is something else that you need to know, and that's called distributional semantics. And distributional semantics builds on the assumption that syntactically or semantically similar linguistics units have similar distributions. It provides information beyond basic linguistic analysis. It is like word similarities, document topics, and so on. And it is very useful in machine learning applications, and it may require massive data sets. Some examples where you could apply distributional semantics is topic discovery, what is the topic of the text, document clustering, or source of machine learning features. Topic discovery, for example, the thing that is being identified here is that and being considered is that the words appearing in similar contexts from a topic, or the topic modeling that reveals themes present in the documents. Some examples of the topics are the ones that are coming together is app, update, version, Android, iOS, for example, or another bunch is a screen, microphone, battery, a speaker. It could be another bunch that comes together as a topic, warranty, broken, replacement, repair, or one other topic could be expensive, cheap, price, affordable. You see, all these things have a theme. And this is what distributional semantic does when doing the topic discovery, find the words with similar themes. As I said, another example of distributional semantics is document clustering. And what is happening is to consider what are the shared words between similar documents, and documents with similar contents are grouped together. For example, these are the example of some document clusters. Our touchscreen is too fragile. I want a refund. My cat scratched the screen of my iPhone 7. How much to get it replaced? Where can I buy a screen protector for my iPhone? So these documents were clustered together because they had a similar theme. Another one would be help. There are no updates to my phone. It's stuck on black screen at boot after the last update. Or will you ever fix this security issue? Basically, these are about the problems with the phone. And you see that this is useful. For example, you're building a chatbot, and the bot wants to get to a specific theme to solve the problem. Okay. So let's get to another application of NLPs, and that is information extraction. Information extraction is the extraction of statements from text into structured words. And some relevant terms here is, for example, a named entity. That is a thing, which could be a concept, item, object that is relevant for the application. And then we have named entity recognition, that's extraction of named entities. Named entity normalization, that is linking extracted entities to identify a relation or event extraction of entity relationships. So why information extraction? Why is it useful? First of all, free text contains facts about who, what, when, where. We could figure them out. A structured information is more convenient than text in information retrieval, question answering, and other tasks. So that is why information extraction basically helps us to take a free text to a structured information database. And also information extraction in a sense normalizes the expression of the facts. And as I said, one of the things that we do in information extraction is named entity recognition. And the entity mentions in the text are identified. As you see here, the entities here, person, organization, country. So Rajiv Suri is the person, Nokia is the organization and country, India is the country. And then the identified entities could be classified. Relevant entity types are task dependent, like person, organization, medicine, location, amount, time, whatsoever. And there are lexicon based and machine learning based methods for doing that. So this is what we call named entity recognition. What is the relation extraction? It is about static relationships. For example, here we have person, organization, and organization has a CEO. That is a person. So basically, this is what is happening here. Rajiv Suri is the CEO of that, is a person that is a CEO of that organization. We could also do event extraction. Uh, it is about, it concerns about the events happening in time, and here this person traveled to the country, so we find both the agents and a destination and then relate them to each other. Information extraction also could be both relation and event extraction. And for that, there are rule-based and machine learning-based methods to do that. Entity normalization enhances the usability of information, for example, linking products to product database identifiers. And the extracted information can serve as a starting point for automatic inference with ontologies. Okay, so that was about information extraction. Let's get to another topic that is quite popular and we hear quite a bit about it, and that is sentiment analysis. What is sentiment analysis? It's basically concerned about the subjective content of the text, and its goal is to identify and quantify the sentiment expressed in text by its author. It's happy, sad, excited, stressed, all these sort of things. Uh, Putting a bit of more context into it, what do we say when what do we mean by sentiment? For us, sentiment is an opinion or a stance regarding a theme, topic, or subject. Its simplest form could be seen as negative, neutral, or positive, and this is something that you're going to do for your mini project, so pay a bit more attention here. You're going to have a bit of hands-on practice on that as well. But it can also concern various subjective aspects like sadness, joy, hate, love, failure, success, and it has both polarity and strengths. So, why sentiment analysis is even important? First of all, opinions and public image influence decision makings. So, it is important to know what the public feels. Sentiment analysis can replace or sometimes supplement market research, user surveys, polls, etc. It also is feasible these days because the amount of user generated text has tremendously increased in the past few years. Examples of text sources that are at our disposals are product reviews, social media posts from Twitter, Facebook, and feedback forms. So what are the examples of sentiment analysis? I'm going to give you a few of them. For example, let's say we want to analyze our user reviews. So we want to see which user reviews are positive. Let me give you an example. I bought this iPhone a week ago. It's awesome. The touch screen is particularly nice. The voice quality is clear too, but the earphones broken in 2 days. I was also hoping for a longer battery life, but it is okay for me. So is it negative or positive? The solution here is the classification. We annotate a sample of document as positive or negative and then train a supervised model to classify documents. For me personally, as a human being, it's not that easy to decipher whether it's positive or negative. I would consider that as a negative one because nothing works, but apparently the guy is happy, so probably it's a positive review. So let's see another example. The other example could be about uh, property rating. And the question to be answered is basically which properties are liked by users. Uh, it is exactly the same text as before, so I'm not going to read the comment as well. But the question is basically different here. It's not that the overall rating was positive or negative, or review was positive or negative, but what part of this product they liked. And the solution is named entity recognition and classification. Annotate properties and their sentiment, and then train supervised model to recognize mentioned properties to classify them. Then we know what parts are positively or negatively portrayed above. For me, for this example, this works better because this is a mixed opinion. It's neither positive or negative, but it has elements of being positive and elements of being negative. Let's give you another example. How the image of a company has developed over time. And the question here is that, for example, what kind of news article or social media's posts have been written in past 5 years? The solution would be sentiment quantification and time series analysis. And by that, I mean that we quantify document sentiments in an unsupervised manner, then analyze trends and anomalies, and then validate the quantification by manually inspecting a sample. Uh, for example, this could be a text. The general trend is positive. There was a dip in product reviews when iPhone 7 was released, but social media posts remained positive. So this is a type of analysis that we could get for the image of companies developed over time. So with that, I am closing the natural language processing overview here. What you need to keep in mind is that natural language processing is becoming more and more important for businesses. And the purpose is to tap to the unused textual resources, which contains much information that are not available anywhere else. Natural NLP normally requires appropriate methods, but also human resources. So this is one thing that at the moment we need to keep in mind. Okay, we talked about NLP so far, and we know what sentiment analysis. I want to show you one example of how does this work. There are of course several different methods, but let's try one and see how it means in practice.